Hydrographs are used to illustrate river discharge. Annual hydrographs show river discharge in relation to the local climate. Over a short period of time, however, they are used to show hourly variations in rainfall and river flow. We call these storm hydrographs. Therefore, instead of cycles or weeks or months, this hydrograph shows variations in hours and days. This line here and the dots across is the base flow of a river. This is the normal variation in the level of the river from the ground flow and water from the local climate. Above this is the rising limb. This shows the discharge of the river increasing. Discharge is the area of the water times by the velocity, and it's measured in cubic meters per second, or cumex. This discharge is affected by precipitation, evapotranspiration, plus or minus the changes in storage. In this case, we can see the levels of precipitation here, and they're measured in millimeters. At the top of the rising limb, we have peak discharge. This is the largest volume and/or velocity of a river following a precipitation event. The time between peak discharge and the peak rainfall, which occurred 8 hours earlier, is called lag time. Put simply, the shorter the lag time, the greater the likelihood of flooding, because the discharge is flowing through the river in a shorter amount of time. Therefore, there's less time for drainage in the river basin. After the point of peak discharge, the river begins to return to base flow. This is called the falling limb. The final factor to consider is the bank full discharge. This is the highest volume of water a river can contain before it floods. The bank full discharge varies greatly river by river. Watch the screen jump of factors that affect the shape of a storm hydrograph to find out more about this, and the factors that affect the lag time of a river flood event.